Alright, so welcome everybody to this first session, and thus welcome to Spring 1 again. Surprised to see that many faces this morning because it's 8:30, sorry, 8:30, and Jürgen speaking in parallel, so I thought, okay, they're probably all over there. This session is called Whoops, Where Did My Architecture Go? My name is Oliver Gierke. I work for Spring Source in the Spring Data team. In case you, that's pretty much it. In case you haven't seen the announcement yesterday, I think Mark covered it in the keynote. We have just released a book written with O'Reilly and that covers the entirety of the Spring Data project. And the reason I mention that here is that every one of you gets a free copy of it. So there. With the white sheets you got yesterday at the registration, there's some promo code you can use until I think after the conference just to get the 100% discount. So in case you'd like to just grab the ebook, feel free to go to. All right. So what is this talk about? I spent prior joining SpringSource, I spent over 5 years in consulting in banking industries, mostly in Central Europe. And I've done quite a lot of code reviews before SpringSource and during my consulting time at SpringSource. And it seemed, or I found some patterns reappearing with each code review. I mean, people just usually hired us to do Spring consulting, but we oftentimes ended up explaining the guys why it's a good idea to implement equals in hash code. There's very different levels of kind of issues they had in their applications. And especially I found some architectural things and things that architecture is represented in code during these code reviews. And then a former colleague of mine discussed these issues a bit, and I thought, okay, it might make sense to come up with a talk summarizing these things and to have that covered sometimes, because most of the architecture talks are very high level and showing you, okay, there's systems and they speak with each other and what have you. And I was thinking more of a senior developer step to architecture kind of level, right? So you're really working with code, but there are architectural decisions that have to be represented in code, and how do you do that best, right? And I was just thinking about, okay, what could make it into this talk, and then I sat in my living room one day and was browsing through the latest InfoQ talks, and I saw one called Whoops, Where Did My Architecture Go? By Eoin Woods. And I just watched it the very first 10 minutes and I thought, damn, this guy is doing my talk, right? And fortunately it turned out that he went into a slightly different direction that I was thinking of after the first 10 minutes, but I was kind of impressed how he actually covered the topic and what he started with. So I dropped him an email saying, okay, I really liked your talk. Would you mind if I just grab that cool fancy title, right? So just caught my eye. And he said, okay, why not? Just send me the slides if you're done with it. And so that's a very, very recommended talk. He's going more into architectural management tools like Sonar Graph and what's the other one? Structure 101. In his talk, I have a link to it in the very back of the slides, so you can have a look at that as well if you want to. Okay, what do I want to cover in this session? There's some kind of architecture 101, so one very core principle I think is important when talking about architecture in the context of a code base. I discussed this a bit. I'll show you two tools that you can use to actually, or that help you with controlling an architecture, maintaining architecture inside a code base. And then when I've done that, or when I did that actually, or finished thinking about that, I thought, okay, how far can you get with plain Java means only? And it turns out that there are some things in very, very core Java principles that developers usually oversee and not consider and that are extremely helpful when just maintaining an architecture inside code. And the third part, actually, the first two things make up about half of the talk, and the third thing here is like a tiny library that I extracted from various customer projects that help you to like write code that is more modularized, and it's built on top of Spring, a tiny, very tiny Spring extension, I think 10 or 15 classes or something, and that you might want to have a look at. I'll show you some example usages of it and what it actually can do. Right. So I've come across this when I browsed through SlideShare recently. I come across a slide deck that was coining of the phrase of the 3C of architecture: constraints, complexity, and change. Like, they're not really triangular, but like three core themes that you have to deal with when it comes to software architecture. And what I'd like to concentrate on in the next few minutes is like the two, even most core C of architecture, complexity and change. And I mean that in a sense of when we discuss like approaches to designing a code base, to designing modularity in a code base, I'd like to take a point of view on that in the context of how does that scale with the complexity that an architect and a code base grows to, and how easily does that allow you to change the code base, right? Does it improve the changeability of the code base, or does it decrease it? Okay, so if there was one core principle, like let's say you're probably all Java developers, Spring developers, if there was one core sentence you'd have to bring down rules of architecture, like software architecture, what would that be? Suggestions, anyone? Excuse me?
Simplicity.
Simplicity? Excuse me?
Make it work.
Make it work. Okay.
Consistency.
Consistency. All very good ones. The one that I came up with was know your dependencies. Because, I mean, when we usually got into the code reviews, the first thing you say, or you come in to say, okay, I need to have the code. I need to have, does it compile? It's the first thing. Or can I build it on my machine? And the second thing is, okay, I need to get some architecture documentation or what have you. And it turns out that most of the projects I saw didn't really have a dedicated dependency management. And I mean, if it really starts at that point, you're in serious trouble, right? The thing is that nowadays with Maven and like dependency management tools that are available for Java, it's actually a more or less solved problem. It's not an entirely solved problem, but at least there is a way to do it like most of the way right. Yeah. You can, of course, have like dependencies on a variety level of granularities, like on modules. That raises the question, what is a module? You can have dependencies between layers. Vertical slices, is anyone having or dealing with vertical slices in their architecture descriptions in applications? Only a few. That's quite cool. We'll cover that later on. And layers and slices usually form subsystems, like with the crossings of the boundary. But we'll go into that later. This is more of a logical kind of thing, right? So how do you structure your application logically? And that, in most of the cases, I mean, I think in all of the cases, it maps down to like physical artifacts. I mean, physical in a computer science context is probably a bit exaggerated, but like in artifacts, like you have Java archives, you have packages, and you have classes. And the interesting thing about this list here is that for two of the three, we have like ways of managing or thinking about dependencies, right? With Java archives, we have like things like Maven or Ivy. Whether Java archive is a real jar or is a WAR file or an EAR file, what have you. For the class level, we have dependency injection, which is kind of like if you're using constructor injection, it's the constructor is pretty much telling you what dependencies this class has. It's exposing the dependency. It's explicitly declaring it. And there's this gray area in between, like with the Java packages, right? Just a question: have you ever wondered why your properties, the properties in a Java class, are private by default? You'd probably do that, right? If you add them. Why do you have public as the default scope for classes? Why is this mismatch there? Right? Why is the default scope in Java the package scope? Right? So you see, there's a bit of room for improvement in the package like level, and I was thinking about that for quite a while, and I've come to some conclusions. That's what I'm about to show you in the next few slides, that which could leverage these packages a bit more, and to use that to manage the dependencies inside your code. Okay, coming back to the layers and slices thing, just to make sure we're all on the same page. Usually you have an application split into layers, right? That's what we get taught in computer science. You have the presentation layer, you have a service layer, and you have a data access layer. Who of you has or is working with an architecture like this? Okay, so you're all working for the same company? Probably not, right? So that nicely shows that an architecture of this kind really is not an architecture. It's just like, okay, an overall way to do it. It gets much more interesting. Okay, yeah, forgot to tell you that. That's probably what we get taught. Okay, presentation layer depends on service layer depends on data access layer, yada, yada, yada. So that everyone knows that. What gets more interesting is the vertical slices. So you have like an core slice, which contains core abstractions of your application. Then you have a customer slice, like customer data, and these customers might have accounts. And you have a dedicated slice for those, right? And you can now come up with dependencies between these slices as well. And the core issue here is that they don't have, or they must not be cyclic as well. So if account depends on customer, customer must not depend on accounts, right? Who's having these I asked that already. Only a few people had these or thought of their application in terms of these vertical slices. Why is that important, actually? Why is it important in the first place to not have the data access layer to depend on the service layer? They would form a cyclic dependency, which is, okay, it's a problem, but it's a theoretical one. The practical consequence of that is, like, if you change something in the presentation layer up here, you cannot break the service layer, right? Like, for the service layer, the same applies regarding the data access layer then. So if you go with the slices in turn, you really want to have like the very same thing for like more business critical slices. Like if you change something in the account slice, you don't want, you want to make sure that you're never going to break something in the customer slice. And the way I usually think about is, would it make sense when trying to come up with these slices, would it make sense to actually deploy an application with only the core and the customer slice? It probably would to some degree. You would have, let's say, a customer relationship management application here, right? And then you add the accounts on top of that. So there's some kind of like exploration going on in the first place, trying to find out what has to depend on what, and what makes sense without what, right? So the classic example here, and actually matching those slices here, is if you have the requirement that customers have accounts, how would you model those? You'd probably go ahead and say that I have a customer class, and the customer class has an account class, has an account property, and the account property belongs to a customer, so we have the very same property and just created a a cyclic dependency here. So that is a bit of a problem, and I use that example in the sample code that I'll show you later on there. Okay, to summarize just the graphics you've just seen, layers are very obvious. It's probably the best to summarize it. A key thing here is that they are less important to business. So your customers probably don't really care whether you have a data access layer and a service layer and like a presentation layer on top. And you always, I mean, that's something you get taught in university, and everyone really knows that stuff. So even, let's say, if you throw in like 5 classes, like a controller, a service, and a repository into the very same package, developers usually know where the dependencies are, right? In what directions they have to be. This is absolutely not the case usually for slices, because the way the slices are structured are usually driven by the purpose of the application, right? They are hardly understood in the first place. When you start the application, the developers not really know. They don't really know naturally where to cut the slices, right? What makes up a slice? You have to discover that and refine it throughout the application development, I think. But they are much more relevant to business requirements, because if you get that wrong, the code quickly gets unmaintainable, I'd argue, or like not that easy to extend anymore, right? Because if you change something in one place and that suddenly ripples up bugs in the other place, then like changes to the code base get quite expensive. Okay, so assume we have defined like our super duper architecture here, and the next thing you probably have to think about is, okay, how do I actually implement an architecture inside a code base? Who of you has an architecture inside one's code base? I'd argue none of you have. Because all we have in the code base is like conventions and stuff, because if you just start up the virtual machine, all of that is gone. All of your unless you're using OSGI and suffer the pain from all the class loaders, but architecture is usually just implemented using conventions, right, inside the code base. Your service classes all end up with service, user service, account service. Your repositories all end up with repository in the name. So the question is still, okay, how can we maybe get more of the architectural description into the code base? Because it was usually the case when we did the code reviews that when I got the code base, and then, okay, have you some architecture documentation, and you get these 200 sheets of paper, and then you just skim through that for a day or so, and then you say, okay, is that a different project you documented there, or? And that stuff quickly gets out of hand. So you're finding some means to get the architectural idea more closer to what ends up running in your virtual machine is extremely valuable, right? So yeah, that's what I pretty much just explained. So there's some natural tension, or like a bridge to gap, a gap to bridge. Sorry, it's early in the morning. So we'll have a look at how we can do that in a second, like more hands-on. But once you got to this point and you decided for some means, even if it's just naming conventions, if it's like stereotype annotations, if you're working with Spring, the question still becomes, in the course of the project, how can you not only implement the architecture, but how can you enforce the architecture in the code base? Because usually you start off with best intentions, have defined means and like packages, and there's some coding conventions going on, but then new developers join the team, and it's hard to communicate that stuff, and everyone just works on its own pace, and like the code base code base degrades then usually quite a bit. And if you don't have means to enforce the architecture, and with enforce I don't mean like being some kind of anyone, I mean Chuck Norris or something saying you must not do it this way. It's rather about detecting when architectural decisions are violated and bringing them to discussion, right? It's not about really enforcing them, but being pinged of possible requirements to change the architecture. So whenever someone feels the need to violate what you've decided on before, there's probably some reasons behind that, and that's exactly the point you have to start to discuss the things, right? Okay, how can you actually do that? Just been talking quite a lot. You can use tools like JDepend or Sonar. Has anyone ever used JDepend? Who knows JDepend? Okay. For those of you who don't, I think there is a demo slide to be prepared. There we go. It's a tool that you can put into your code base, not into your build, integrate into your build, or there's an Eclipse plugin for it, which is what I'm using here. The code you see here will guide us or follow us through the entire talk. There is a GitHub project, the link is in the slides in the end, that has all these projects in here. And what I'd like to start with is like we're going into the packages thing later on, I told you. And with the Eclipse plugin installed, you can just like have a source folder and run a JDepend analysis on it. And what that will do is, there we go, that makes sense. It will just inspect all the classes you have and the cross dependencies between them, and it will show you that you have cyclic dependencies between packages, which is something you of course should avoid, because as I told you in the first place, whenever you have cyclic dependencies, you can't really change one package without affecting the other, right? The problem with JDepend, I mean, it's quite neat to briefly see that you have issues. It's just, well, not close to impossible, but very hard to find the dedicated spot where that violation actually comes from. We just see we have, you don't even see how many cycles you have. In fact, in this code base, there's exactly one package cycle, which gets indicated by like 6 or 7, 8 actually, like these yellow exclamation marks over there. And you can find out by just walking through the packages and looking at, okay, the customer package depends on the account package. Ah, okay. The account package depends on the customer package, so that's probably the issue. But that's far from obvious, right? But it's still just a neat tool which doesn't need any setup except like installing it and just running it into your code base, and you probably will find your code base with quite a lot of these yellow exclamation marks, because if you're not really starting to control this from the very beginning, it's very easy to accidentally introduce those dependencies. Okay, that's just it. Zero setup time. I just regularly use it when we work on the Spring Data projects, just to regularly check, okay, when I put new classes into the code base, did I just introduce a cyclic dependency? That's pretty much the flag here. The other tool I'd like to show you is called Sonar Graph. It has been known as Sonar J, which should not be mixed up with Sonar. Sonar is the static code analysis tool, kind of a dashboard for code quality. Sonar J is like a dependency or an architecture management tool. And I've prepared a demo for that as well. There is what you do there conceptually is you have this like Eclipse-based Sonar Graph architect, how it's called, where you can load your Eclipse project into, like like the code. You need Java source files and compiled code. And then you go ahead and define a logical architecture alongside its dependencies. Right? You say you can actually add a layer, you can add a vertical slice, and you can then define with these green arrows here which layer is allowed to depend on which layer, right? The same for vertical slices, and you've seen here I have defined that the account package is allowed to use the customer package. Slice, of course. Sorry. What you then do, there goes the important part, is you can create assignments, type assignments to these architecture artifacts. Like you can say, all the packages of my application that have some account thing in it, they belong to the account slice. And all the packages that have the customer in it, they belong to the customer slice. And by this way, you transparently assign types to these like boxes here, like the domain layer of the accounts slice, which is over here. And you transparently assign them just using these type assignments, right? And that will actually then discover violations of these rules you just made up. And you can just explore those by, there we go, by using this exploration view here, and that also shows you like the dependencies. They have to be read counterclockwise, right? So the green, like counterclockwise. The service layer, for example, go here, depends on the repository layer, it depends on the domain layer, it depends on external services, of course, and the web layer depends on it. Right? And what you also see here is that we have this red circle in here, which circle stands for cyclic dependency, and you can clearly see that the customer, according to my architecture description, the customer has an unwanted dependency to the account class, right? And you can actually jump right to it, and it tells you that, no, the arrow marker should actually walk with us, but it tells you that the code is not really important. It's just you see the arrow marker right at the line in the code that introduces this dependency. So it's more easy to spot that stuff, and what you can also do now is, if the architecture violation can be solved by moving types around, right? Like moving types to a new package or something, then you can do virtual refactorings in here. So you can move types between packages and virtually, and then see, okay, what results would that actually bring regarding my architecture definition. And if you're satisfied with what you've done, you can export those refactorings and apply them in Eclipse. Okay, so that tool is kind of neat for like coming up with an architecture or modeling an architecture in the first place. I mean, you have to come up with it yourself, of course, but to just model it, to really define it, the file format that is stored, or the tool uses some arbitrary XML format. So you could theoretically, if you prefer writing XML, you can just write down the architecture definition in some DSL or something. And you can like explore existing projects. That's why I used it for the code reviews mostly, for dependencies and possibilities to actually break cycles up if there are some. And I'd argue, or I'd not promise, but I guess that most of the projects you have you find some tiny glitches in there. I mean, you still can discuss how important that is and how crucial it really is, but at least you get awareness for these issues. Okay, so you now have someone using that tool. It's free for, I think there's a community license for projects until 50,000 bytecode instructions or something. I'm not sure about the exact number, but it works for like small to medium-sized Java projects, and I think the license is about 500 euros or something for the architect, which is in the context of a bigger software project, probably not that of a big deal, and well invested, because I know I've seen a tweet recently saying, if you think architecture is expensive, try no architecture, and that neatly sums it up, I think. So if you have this guy one guy defining the architecture, like the Iron Tower architect, right? You can now go ahead and expose that architecture to your developers by installing an Eclipse plugin and saying you can assign Eclipse projects. Yeehaw. Do I have internet down here? I should have a valid license. I know I have. That works. Anyway, so just, yeah. You can assign the projects in here, right? Say, okay, here's my architecture description file, and I think there should be one in the Spring Data projects. There is, it's in the parent project. Don't know if that unfolds correctly, no, but there's one in like Spring Data JPA, for example. There's this Sonar graph file. I assign that architecture description to the project, and what that then does, you can configure it to some degree. It triggers like the all the architecture violations you introduce to the code base. You see them as compile errors right in your IDE, right? So you can, let's say, you can define an architectural rule saying use of reflection is not allowed, and whenever you refer to Java lang reflect type in the Java lang reflect package, you get like compile errors there, or lower the severity to warnings. That's possible as well. But you get feedback right inside the IDE about that you've just violated an architecture decision, which is not something or as I already mentioned, not something I think is like a hard barrier, but at least raises awareness to, okay, we have to talk, right? Do we have to change the architectural definition there? Because this is a new requirement that it makes sense to change it? Or should I just solve it the other way, move the type around, rather depend on an interface instead of an implementation class or something? Okay. That's pretty much it here. Right. Okay, so there are tools. I've shown you the demo. So you've seen there are tools that you can tackle this problem with. What I try thinking about is, okay, how far can you get if you just use plain Java means? Because using the tool adds some overhead, of course, to your development process, and especially as we're like usually small teams in the Spring Developer world, it raises the question whether it really makes sense to introduce the tool. We get Sonar Graph license for free because for open source projects they have free licenses as well. And I'm used to work with that tool, so it's not that much of an overhead to have consistently scan the code base against these rules. But how far can you actually get if you just use plain Java-based means, right? Right, that's the question. Okay, so going back to that architectural description, what is usually the way you represent that grid in your code base? Package names, right? So you all have service package, and like you maybe even have an account package, a customer package. But the question here is, which order do I do that? And you could probably even raise the question, does it really matter? And I think, yes, it does. And I'd like to show you why. So just mapped onto our domain, onto our architecture we just saw, it was domain.core versus core.domain versus plain core, customer, or account, right? That was the third option, stick with slices only. Okay. layers first. If we have the layers first, I'd probably just go back, and this is just summary. If we do it this way, what are the consequences of that? You've seen that the service layer and the repository layer, and the service layer depends upon the repository layer. So for the service implementation class that is probably in the service package here, it needs some access to the repository interface, right? So if the repository interface is in this package, it needs to be public to be accessible to the service implementation, right? So assume we had, this is not the domain package here, but rather the web package on top of the service thing. The service interface has to be public here as well and to be consumable by the controller. So you create some kind of natural tension to have public types because you need to access them from each and everywhere. And yeah, so you get public types in most cases. For this way here, let me step back again. Another consequence is that it's when you want to, let's say, remove a slice from the code base, you have to remove quite a few packages, right? All the packages that end with core, or if you add a new slice, you have to add 3 packages here. With the other way around, you get like more cohesive structure of your code base by just, okay, everything that's in core slice is in the core package, like in the directory of the, that it forms in the file system. Other than that, everything still stays the same. So you still have the need to have public repository interface, service interface, and on the web layer, to let it be consumable from a controller or something. Right. So still public types. What if you go with just that? You don't know actually. I mean, you have the slices in the very core of your decisions then. Whether the customer slice is implemented in some kind of layered architecture with service, repository, whatnot, is totally opaque. It doesn't have to be, right? So the layering becomes something of a slice internal, and you don't have the need to expose the repository interface from the customer package in case only the customer service uses it, right? There's this classical example I'd like to bring at that point where you have, let's say, a user repository that stores users. That's what it's supposed to do. And you have a user management kind of service on top of that that takes care of creating default passwords when you create a new user, that takes care of encrypting the passwords, and yeah, just that. So if you expose the user repository to the entire code base, someone could just go ahead and create a new user instance and store that. The password would not be created, the password would not be encrypted. So you kind of want to enforce that all the client modules of the user module consume it through the user management interface, and you can't really do that if you have to expose the user repository, right, to other packages, because there's no way to say, okay, I only want to expose it to a certain package, but it's either all the world sees it or no one. And with that kind of approach, you can actually have that, right? So the user management interface would be the one that is public. The implementation can be package protected. The interface can be package protected, and what have not. Okay. Summary. Layers first, leak slice internals. So the structure of a slice actually becomes visible to the outside world. With slices first or slices only, you keep those implementations private. and simply like improve, not improve, but well, still improve. You have like natural Java language means that you can use for coarse-grained like decisions of whether you want to expose a type to others or not, right? And the other thing that comes as a side effect is that the application structure is more driven by the slices and by the business slices, by the business functionality. And I'd argue that if you look at a slice, and you will see that in the code base, if you look at the slice that it say, okay, customer and accounts, and it has repository, service interface, service implementation, controller maybe, or domain objects in there, a reasonably skilled developer can still make up his mind on, okay, what depends on what, how is it working together, what have you. If you just scatter your types all over the packages, it becomes just a nightmare to find out, okay, what depends on what, and how are the dependencies between the slices and stuff. And that gets much harder because there's so many public types, and you have to look, okay, this could be used from somewhere, and you don't know if it gets used from some client or what have you. Okay, so that's at least the rule I apply to the code I write nowadays. It's like, okay, less packages, and if it's not, first of all, don't make classes public by default if you don't need to. I mean, we're developing quite some framework code, so there usually is some need to make them public, but yeah, just the least visibility can also mean just having extract some code of your class inside some static inner class or something, because if that creates a reasonable abstraction and is only used inside that class, yeah, you don't have to expose it to the outside world. Okay. Yeah, what that actually leads to, I don't know if you've seen the animation, is if you just choose a package structure like this, that you actually had these boundaries equally wide in the first place, but you come to a more like slice-driven application structure that could eventually lead to like the account slice being extracted in a separate Maven module or what have you, but it doesn't have to necessarily. But like the layering, the things that are obvious anyway, become some kind of internal of the slice, and you get much more control over the dependencies here between the slices, right? Because if we stick to the user or customer management service, if you only expose the service interface here and don't have to expose that, then all the other slices that will come up here over here can only use that single interface, right? And not like 15 or 10 types that you're potentially forced to expose just because you chose a particular package structure. All right, let's have a look before we go into that. There's a demo slide missing. Before we go into the next topic, let me just quickly set up the Java text editor font too, because it's probably a bit hard to read in the back, right? And we take that, and then there should be just a plain text kind of thing. Where was the text font? There we go. I go with that as well. Okay, just to show you what this means in a practical code basis, I have created these packages before, packages after project, and the packages before thing structures the packages in the layers before slices kind of way. So you have like the domain layer with entity classes, an account and a customer, and the account repository, customer repository. You have services on top, and you also have a dedicated web package with web configuration, account, and customer. Right? There should be some test cases here. Yeah, so it's like a buildable Maven project. with Spring Java config and also with Spring XML configuration. So if you have a package structure like this, you see account service is public, a public interface, the repository interfaces are public, and thus they are consumable by everyone. And what I've tried to come up with, I just told you the example with the user repository and the user management that adds functionality on top that you want to make sure gets executed. I've tried to create something similar with some customer number generators. So instead of passwords, we have a customer number generator that whenever you create a customer here, the customer number gets generated, and you can the service then creates the customer instance, applies the number, and saves the customer, right? So now that you have the customer service, the customer repository being public, there's absolutely no one preventing someone from just getting access to a customer repository, saying add autowired private customer repository, new customer, go, right? Saving customers without customer numbers. So that becomes an issue, or is an issue actually. The first thing that you could do here, which is not really solving that problem, but I don't know if you're aware of, that Spring can actually happily instantiate package scope classes or types. Like I'm always like, if you have this kind of interface implementation structure for your classes and interfaces, then you can always make the implementation class package protected, and Spring will still be able to create beans of it, and you thus prevent someone from referring to implementation classes in the first place. I mean, because you'd always want clients to refer to the service instead of the implementation, because otherwise you might get into issues if you apply transactions with Spring AOP proxy. So you really want to force clients into using interfaces, and you can do it with that by just preventing the access to the implementation class entirely. Right? Okay, so the cleaned up project structure looks something like this. I almost completely got rid of the layer packages. I just have account web, customer, and customer web. The reason I do that here is that it usually makes sense to separate the web part from everything else, because the web layer of an application usually creates or introduces quite a lot of new dependencies, like to the web framework, like you need some web XML going on. So that it makes sense to have or consider the backend of the application to be everything up until the service layer interface, and expose that, and then have the web layer to expose that functionality. That's the way we actually consider to expose the Java functionality into HTTP, right? If you want to speak it from a technical point of view. So for the customer layer I just showed you, we now have the customer class being public. Is it public? It is. Customer number is public. Customer number generator still it's just a plain helper class here. It's package scoped. The repository interface is package scoped. Customer service is public, but the implementation class is package scoped as well. So I'd argue that when you look into this package, you probably can make up your mind, okay, what is this stuff doing, and what are the different layers? You can still see them, and you can so there's no need to really express the layering in the packages, I'd argue. But and you essentially lower the number of types that are exposed publicly. So you can now not actually, if you go to the test source test Java, there should be, you cannot actually have the customer repository, add autowired customer repository. It's just not visible, right? That's, I mean, long story short. All right. Questions so far? video. Gosh, okay. Shall we go to subsystems? Yeah, so I've been working for been architecting an integration system at a German public bank right in the days of the Lehman Brothers collapse. We actually took the real-time trading, the trading data. We got that stuff submitted, deals submitted over a typical message broker, and then had the task to automatically use this data to feed the risk management system in the back end, right? Some very core integration task, and if we restarted the project today, we probably would have used something like Spring Integration for that. But it essentially was listening at a message broker for some XML data, transforming that XML data into some risk management specific format, which the rules were pretty much like per financial instrument. We had a requirement specification of about 150 to 200 pages, where 80% of them stated just leave it as is, right? Because we were migrating from a Python script-based semi-automated risk management solution, which is kind of fun if you think of how banks work nowadays. Yeah, so we migrated to a Java Spring-based application there, and the idea was that because there were so many financial instruments to be actually covered by that system, like equities, options, what have you, that we would like to have the project move in certain steps, and we would like to go on an instrument by instrument basis. So we want to add equities and options first. We wanted, but never really finished, to do certificates, because for some reason the bank decided not to deal certificates anymore back in the days. But generally, from a just moving forward perspective, on an instrument by instrument basis. So there was there was the requirement. Okay, this is probably becoming very big system, and we need to add stuff one by one. So the two C's apply here again. So we have quite a bit of complexity inside the rules of how to transform the XML into that very specific string-based stuff we need to send to the risk management system. And the system will change. It will definitely change during the course of development, and we have to add new instruments one by one. Okay, so how do we actually localize the change, so have dedicated points so that whenever we add the options, we don't really have to touch things for like equities or stuff? And the core theme that this all boiled down to is we separate the things that will change frequently from the infrequent stuff. So we had some kind of a core system, a core system that provided basic functionality, the basic workflow, the basic steps like validation. There was some XSLT transformation going on, JAX-B binding, implementing the rules on top of the Java, the JAX-B bound objects, and then on the very end, like transforming those into the string representation we need to send to the risk management system and actually sending it. The frequent change were actually the rules that had to get applied for each of the financial instruments. So there were product codes to be built for options in a totally different way than they were for equities. There had to be validation rules applied during the just when the incoming message came on, came in for equities compared to the options, right? So they were pretty much instrument specific, as we call them. And we decided, or there was some question. Okay, how can we actually, in which granularity do we want to structure that stuff? And we decided to go with Java archives. So we had dedicated archives for the instrument-specific code, like an equity plugin, an options plugin, and I think the core system consisted of 3 or 4 different Java archives that made up just incoming, validation, transformation, and what have we. Okay, so there's a host system, and that host system exposed some SPI like interfaces, plugin interfaces that the plugins could then implement and actually could enrich the host system with functionality, right? So assume the first SPI thing here is the validation stuff. Here we have like the logic, the rule logic to construct the actual data to be sent, and maybe some modifications on the actual sending, depending on, let's say this is equities, this is options, and the equities have some validations going on, the options don't, so you can selectively implement just the interfaces, right? Okay, so we've done quite some PowerPoint architecture now, and that seems reasonable. There were some organizational and technical requirements here, so we're not allowed to use OSGI. We started deploying on WebSphere 6.1, and the original architecture before I joined the project was based on like message-driven EJBs and what have we, and we got rid of that, fortunately. All Spring-based. We wanted to have build time composition, so that's actually why OSGI also was not really an option, or not really a reasonable candidate for a technical solution to it. We wanted to have like prepare the projects. Let me just go back here. Let's say we have a single jar for the host and a single jar for the plugin, and we wanted to be able to have, let's say, another Maven project that says, okay, we take this, we have a dependency to the host, we have a dependency to equities and to options, build that, and let that create a deployable artifact, right? So that you could, let's say, with another custom build, maybe remove one plugin, just remove the jar, and still would things would still work as expected. So no runtime exchange of jar files or something. And crucial requirement, we don't want to change or touch configuration or anything of the host part of the system, right? Like the skeleton system should never be touched just because we add like yet another financial instrument. Okay, so from a runtime perspective, you create a Maven project, declare dependencies to the 3 jars, and bundle that up in the first place. It still was an ear because we had to include some JCA adapters there, and we ended up with that entire thing being a jar itself, and so moving away from WebSphere 6.1 to Java-jar eventually, which was or the administrators at least liked very much. Okay, so the question here is, how do you structure the system, like also from the Spring point of view, to make the host aware of the plugins, which, if you go to the Spring specific part, is how do you dynamically collect Spring beans? Because you might come to the conclusion that, okay, each of the plugin jars declares some Spring beans, and somehow the host Spring beans just have to get all the ones found injected, right? So some of you might have stumbled over the class path star kind of protocol handler in Spring, which allows you to essentially find all the files that are at a given location in your class path. So we agreed on just like meta in Spring, usual location, and then plugin context XML, and by an import statement using this as target inside the host plugin, we could dynamically just see the configuration files that the plugins provided, and get string beans collected as well, right? So we had, if you're going back to this, we have this import statement in the host system, in the jar, and the plugins actually provide these files then, and thus we get, if we just now create an application context with this as class path, these string beans declared in here will be instantiated as well, and now we still have to find some means to wire the beans found in here to some bean in here, right? So how do you do that? With annotation configuration, it's quite easy because you can just have a list of type as parameter of a constructor or setter, and if you auto-wire it, the container will inspect all the beans whether they implement that type and just inject them here, right? That's kind of, who is aware of that? Okay. Quite some, which is new. So this comes in quite handy, right? So you can pretty much just collect all beans of type X, which is kind of nice because this type here is just one of our SPI interfaces, like the instrument validator, for example. And then we have an equity validator and an options validator implementation class, and the client could just get access to those. So you could now do something with these plugins inside some core component method here, right? I don't think, I mean, I can show you that, but I don't think that's necessary. You can just try it out, like putting list of something into your constructor, and then you get all the components in there. So this works for annotations, but it's one of the rare cases in Spring where there's no XML equivalent of that behavior. And so nowadays, if you have Java config or use component scanning, that's probably not a big deal anymore. But yeah, we created a tiny namespace that just does or allows to do the very same thing, like a list of types. You define a type and you get all the beans collected at that place. The other issue here is that you still now have to code quite some logic to say to react on the actual type at runtime, right? So assuming we had, like, my plugin is like the validator kind of thing. We have instrument validator and we have an equity validator and an option validator. So it probably only makes sense to invoke the option validator with option objects and the equity validator to invoke them with equity, and yeah, I think you get the point here. So you have to somehow like iterate over the instances here and select, by some means, select the appropriate one and then invoke that one, right? So that requires or would require some boilerplate code, right? So you might want to select the first plugin you find to invoke, if there's really just one plugin that can satisfy the need here. For the validators, you could imagine you have like a common validator that just checks for some ID or something, and then equity-specific ones. So you might want to select multiple of these instances to invoke one after another, right? Or try to look up a particular plugin, or use a default one if none was found, or throw an exception if none is found. That's what led us to develop some infrastructure code, which eventually made it into some very, very tiny helper library that is on GitHub as well in the Spring Source account. And I subtitled it the smallest plugin system ever, because I think the core functionality is 3 or 4 classes, and it basically has 2 core abstractions like a plugin, and the plugin exposes some selection criterion, so which means it's like with the validators I just mentioned, the plugin is instrument specific, right? So you can have plugins for particular instruments. The selection criterion is exposed through a callback method, and the implementation can then decide whether it wants to support a particular instrument type or not. The second part, you see that in a bit, the second part is a registry which gets equipped with plugins and that exposes like methods for these access patterns I just showed you. So what we have here is like the interface plugin of T supports delimiter. So we would go ahead and say instrument validator extends plugin of instrument so that we actually get a supports instrument type here. And the plugin registry just looks like, okay, you have a plugin and you have the delimiter here so that you can eventually ask the plugin, give me the validator plugin for an option. Give me all plugins for option, like in case you want to have multiple instances invoked for or selected for a given delimiter. Right? So very easy API, and that's just the way you use it. You instead of just having a plain list, you have this plugin registry, and the plugin interface here has to extend, of course, the plugin interface, which gets you a supports method with argument T, like just using regular generics. So what you can then do is ask the registry for, like, give me the plugin for a particular parameter, and then call the business method that you declare here on that selected plugin. Right? That gets. I show you that stuff like with the equity and option example in a bit. That probably gets more or you understand it a little bit easier because it's probably a bit theoretical at that point. The implementation of the plugin registry is the orderware plugin registry. It respects the order annotation or the ordered annotation interface. Like when you have multiple plugin instances, the order they get invoked eventually is probably crucial. So you can just use the standard Spring order annotation to make sure that the plugins are found in the right order. And you can, of course, reverse them because we actually also implemented some kind of bootstrapping facility for the application where you had to make sure that like a life cycle went on start, on stop. And you have to make sure that the components potentially are started or stopped in the exact opposite order that you started them. So you can just reverse the plugin registry and get a new plugin registry which orders the plugins in just the other. Oh gosh, who did that? In the other order. So there's some glue code around it. So you have a factory bean that it's easy to set up in standard Spring code or in Spring Java config. There's a Spring namespace, and to ease that setup in XML much more, and it's lazy eval. So yes, you can have not cyclic references, but plugins depend on the registry again to look up other plugins. I'll show you that in a bit. Who made these slides? My dear. It's on GitHub, Spring plugin, Apache 2.0 as you used to, and we have some Spring integration as well. But before we get into that, I'll show you more hands-on what this stuff is all about. How much time do I still have? 20 minutes, right? That's kind of cool. Okay, so what do we have here? We have a plugin core, just from structurally. We have a core which is kind of the host, the skeleton system. I'll show you what it does in a bit. Then we have two plugins, one for equities and we have one for options. And we have an app which is kind of the wrapping project that just does the unsupported instrument. Okay, there should be a test case here using Java config. Okay, that includes core config. Okay, I'll probably go into the core first before we look into that. So what do we have here? In case you wonder, it has been called Hera before it became Spring plugin, so that's why it's still in the package names here. So what we have is we have a very generic, I call it deal processor. The deal processor processes the deal and creates a result, right? So all you domain-driven design people will just bash me for all these generic terms, but yeah, just for this case. I think I chose a much better name for the next one, which is the fee provider. Where is it? Transaction fee provider. Ooh, very specific. Okay, so we're assuming that the processing for the processing of the deal, there's some transaction fee being calculated based on what instrument we need to process, right? Because, I mean, let's just assume equities are much easier to process than options because there's a level of indirection going on there. So we want to just have this implemented in an instrument-specific way, right? So we have a transaction fee provider that calculates the transaction fee for the given instrument. Thus, it's a plugin of instrument, right? So we have a fee calculating deal processor. So we're a modern bank, so all we do is calculate fees for doing nothing. So what the component is set up, you see, package scope. You see we have a client, we are a client for this plugin registry, so we will deal with very different transaction fee providers, but we don't really care about the implementations because we can generally deal with instruments, right? So we get that injected here, and the core logic is whenever we get a deal into the system, we look up the instrument of the deal and try to find the transaction fee provider and then call get transaction fee for the instrument, right? And then give back a default result that only consists of the fee. So you get nothing back but cost, which is the way it usually is. But you see there's nothing equity specific, nothing option specific in here. It just does it the way. And right now what we're doing here is if we don't find, that's where we get pipe in this exception here, if we don't pipe in, or we don't find any plugin for the instrument, we throw an exception, right? Okay, instrument is probably, yeah, it has an issuer, that's pretty much it. There's a deal that has an instrument, deal processor, core config, the result, yeah, that's just the interface, default result, there we go. Core config. Okay, what does the config look like? We use the plugin registry factory bean. We set the application context that we write, and we say, okay, this plugin registry should contain all the beans of type transaction fee provider, and we return that for to be able to or to be exposed that to the application context so that our fee calculating deal processor can get that injected. Yeah, we instantiate that using component scanning here. All right. So what we have in the next step is that equity specific implementation. Yeah, you now have an entire team just implementing equity logic, and the equity here is an instrument, and we have an equity specific transaction fee provider. And the logic in here is quite easy. We say, okay, whenever this, so we, in the first place, we say, okay, we only want to be applied to equities, right? So we check whether the instrument is an equity, and we get that back. So it's safe to cast to equity in here, right? Because we expect to be only called after supports was called here. So we cast it to equity, and then because we sneaked that into, we did some consulting at the bank, right? VMware consulting. So we changed the code slightly to remove the fee or return no fee at all if it's VMware equities. But otherwise we charge you $10.50. 50 cents, there we go. Okay. Quite some simple logic, but I think you get the point here that it could be much more sophisticated stuff in here. So we have some equity configuration that only does component scanning and actually picks up the component here so that it gets part of the application context. So our application is now going ahead and including the core configuration, and the core configuration does a base package scan. So the equivalent of the import of the plugin specific XML file I showed you in the slide deck before is like the base package, and the base package is of app is the whoops.hera package. So as the equities code is in the very same package, the package scanning picks up the configuration class, and we say, okay, component scanning, and thus in turn we look up this one here. So by just including or bootstrapping the application context with the configuration class from the core project, we automatically pick up the plugins that are in the class path. And I've actually checked out if a dedicated branch of the project. I can increase that a bit. It's the equities only branch that has just a slight modification to the POM, because it depends on the core project, of course, and the equities only. Right? So we only pull in the equities plugin into the class path, and what we can then do is, or what we essentially do is, create a new deal for Deutsche Bank equity, and then we invoke the processor and make sure the fee is 10.5. We have for any unsupported instrument, we want to make sure that the assertion is probably a bit stupid here, but it's not stupid because I'm going to change the code appropriately. We expect the unsupported instrument exception. And then we have like VMware equities is free, so we just make sure that we get the 0 returned for that stuff here. I try to run it. Fingers crossed. That worked. Okay. So that's fine. So far, it just adds layers of indirection, right? But to show you that this stuff actually comes in handy, I'd like to switch to the master branch. And refresh the package here. So the POM now also includes the options plugin. Yeah. So we just added another jar to the overall application, and the options plugin is structured as follows. It just looks very similar. The option has an underlying instrument. So I'm not sure how far you're familiar with financial instruments, but the option is like targeting a target instrument that could be anything at all. So what the logic of the transaction fee provider essentially says, because we have this indirection, we'd like to multiply the fee of the actual underlying instrument, whatever that is, by a factor of 1 or 2, right? So here we have a situation that we have a plugin that actually relies on on other plugins to be present, because we inspect the option, get the underlying instrument, and then ask the plugin registry in turn, give me the transaction fee provider for the underlying instrument, whatever that is, right? And we get some feedback there, and multiply the fee with the given multiplier here, right? Okay, so what we're doing now in the test case, that should have slightly changed. Process options. There we go. So we don't have to really change the configuration setup, which was like the requirement not touch the core system, right? There's no change. I can actually show you the diff of the branch here. I don't know if you can see that in the back. So I actually removed the options thing, and I just removed the test case. So I'm not really changing the core system, but only add another test case, right? Which is, in this case, the options deal here. We can option of the equity, Deutsche Bank, and still invoke the processor as normal, but just make sure that we have the multiplication applied there. intern, and that should still work, right? So the final thing, no, I probably just don't go into that, as we're done, 10 minutes to go. So you can, it's probably just worth checking out the sources a bit and playing around with the stuff. What I'd like to take you out of it regarding the Spring plugin library, I mean, it's, where do I have it? It shouldn't be, it's plugin core, it should be somewhere. There we go. It's essentially, gosh, yeah, let's say 15 classes or something. Most of that stuff is the XML namespace integration, but it's a very, very thin layer on top of Spring that just allows you to focus on structuring your code more in terms of the business slices, which brings me back to the original thoughts that we discussed with slicing versus layering, that I thought, okay, it makes sense to concentrate more on the business slices you have, and you can express this focus on that stuff by structuring your code base around these vertical slices. On the one hand, inside a single Maven module with the packages approach, as well as if the systems grow bigger, just extract certain parts, create a tiny plugin-based architecture on that, and have the code separated by task or by vertical slice, more or less. Okay, so let me just run down. There is Spring integration, which essentially is a dynamic service activator that can inspect parts of the Spring integration message and pipe that into the plugin execution as the delimiter. So if you just transfer a financial instrument as payload of a Spring integration message, you can have expose the plugin registry, or that dynamic service activator will actually look up all the beans, like this way. It will create a plugin registry behind its back for all the beans of a given type, and then dynamically inspect you can define what should be the delimiter, and it will inspect the Spring integration message and look up the samples, the actual plugins that match the delimiter or and then invoke those, right? So I think I've done that as part of some customer engagement where they were actually using Spring integration. I thought, okay, that might be an appropriate solution to it. I showed you the demo. Key takeaways: know your dependencies is the first thing. It starts at Maven. It ends at dependency injection on classes, but it also makes sense to monitor your dependencies between packages. And I recommend to start as strict as possible, because there's always an option to make things public as you go. But if you start public in the first place, then there's usually no way to take things back or close them down again, because there will always be someone having a dependency on some public type you never expected. I mean, just ask Jürgen what people depend on in Spring Framework. It's kind of weird. Okay, so two recommended slide decks or talks. Eoin Woods, I already remember that. That's a link actually, which you can click on, and the one of Uwe Friedrichsen was the one where I took the 3C of architecture from. So in case you want to look at that, that's it. Okay. Some links, other additional resources. I linked the Spring Data JPA project because we have this Sonar Graph architecture file in there, and it's not too big to be inspected by the community edition of Sonar J. So in case you just want to grab the community edition of Sonar Graph and want to see how an architecture definition looks like and just play with it, grab this project because you have an architecture definition in there. Grab Sonar Graph and go ahead. And Spring Plugin is just on GitHub. There you go. Thank you very much. Any questions so far?
Would you be able to suggest
Excuse me?
Code samples?
Code sample. All the code samples are in GitHub. Add a whoops I'll add that link to the slide deck. And they are all in GitHub under my personal GitHub account, Oliver Gierke. But I'll add that to the link to the slide deck so that you can just grab the slides and then just get routed to the code base. Any other questions? One more.
For long-term maintainability, I noticed you're using Java config.
Yeah.
Do you think that Java config is better than XML for, like, as projects get very large?
So the question was whether Java config is more handy than XML configuration in terms of scalability and long-term maintenance. And I think yes, because you can refactor them more easily. Although the tool support for the XML stuff is quite sophisticated in STS, I just like, it gives me a cozy, warm feeling to have non-XML in my application. Yeah, so just as you can...
would go annotation over XML if you had your druthers?
I'd go for annotations at my application components, like add service, add component, so that you don't have to configure each bean explicitly. But for all the infrastructure configuration, like data sources, JPA configuration, go with Java config. I mean, that's just much more convenient.
For the Spring integration, you plug in service activators.
Yeah.
Is that like one, or can you have like all that support, or can you do all the various calling options?
The calling options I think that are in place right now is invoke the first one matching or invoke all matching. You're welcome. Okay, so then have fun at the rest of the conference. Take care.